All right, guys, are there any questions on the homework? Any of the assignments so far? The first thing we're looking at is the fundamental theorem of algebra. Fundamental theorem of algebra. Now, we've been using this a little bit already. We just haven't specifically named it as such. The table shows polynomial equations and their solutions, included the repeated solutions. Notice for the last equation, the repeated solution is -1 and it's counted twice. So when we look at this first one here, we have 2x minus 1 equals 0. Well, the degree is 1 because the biggest exponent on the variable is 1. The solution for this is 1/2, and the number of solutions that we have is 1. X squared minus 2 equals 0 is the next one. Well, the degree is 2 because we have x squared. The solutions for this here are going to be plus or minus the square root of 2, which gives us a total of 2 solutions. Let's get a highlighter. We had 1 and 1. We had 2 and 2. Now x cubed minus 8, the degree is 3 because the biggest exponent is 3. The solutions for this here are -2 and -1 plus or minus I squared of 3. Well, that gives us a total of 3. And the last one, x cubed plus x squared minus x minus 1 is a degree 3 polynomial function. And the solutions are -1, 1, and 1. Well, what do we notice about the degree and number of solutions? They're the same. And according to the fundamental theorem of algebra, if a polynomial of degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers. Okay, well that makes sense because we can write any number as a complex number. Such as x is equal to 4. Well, I can rewrite it as x is equal to 4 plus 0. All right, we can write any number as a complex number. So all polynomial functions will have at least one solution in the complex number. And that's kind of interesting. Now, corollaries are something that comes from the theorem itself. And the corollary for this here is if a polynomial of degree n greater than 0, then the equation f of x equals 0 has exactly n solutions, provided each solution repeated twice is counted as 2. So that tells us whatever the degree of the polynomial is how many solutions we'll have. And we do have to count repeated solutions more than once. Therefore, how many solutions does the equation x cubed plus 3x squared plus 16x plus 48 equals 0 have? Well, they would end up being -3, 4i, -4i. Because that would be what the 3 solutions are. How many solutions does this function have? 4. 4. And if we wanted to list them, it would be -2, -2, -2, and 0. Questions on this here? Well, how many solutions would this one have? Because the degree is 4. How many zeros? 3. So it would have 5 zeros because the degree is 5. So the number of answers that we're looking for this here is going to be 5. Now, what can we do and how can we go about finding them? what can we do first? We can graph it. There we go. Okay. I hope that that's full screen. That's better. So we can click y equals, and we would have, well, I'm going to clear that out first, x to the fifth over plus x to the third minus 2x squared minus 12x minus 8. And when we type that in, we're going to hit graph. So looking at the graph, how many zeros do we have? 2. Now, at -1, it touches the graph, but it doesn't cross, correct? So how many zeros can appear there? 2, 4, 6, an even number. Is any time a graph touches the x-axis but does not cross it, we call that having an even multiplicity. So the numbers of zeros at that location is an even amount. Whenever it crosses the graph, like at 2, it's called to have an odd multiplicity. So it could have 1, 3, 5, 7. It could appear more than once, but it's in an odd amount. So, well, hold up. So what we can do to look at the numbers to make sure is we can go second graph, and we see at -1 it is 0. And at 2 we have 0. Is there a chance, going back to the graph, that if we extended the graph out to the left and right, that it'll possibly cross again? So the end behavior, because this is an odd degree, yes? And the leading coefficient was positive. So going out to the left, it should end up going down, and extending it out to the right, it should end up going up, yes? Is it doing that? So if, for some reason, one of these sides going out decided to come back up, or the left decided to come back down, really wouldn't make it odd, it'd make it more even. So most likely, that's what it is, because we don't expect it to turn around. So let's check these here. So we can check -1 first. Any questions on any of this here? Now we would have 1 for x to the fifth, and then what would come next? 0, because we don't have an x to the fourth. Then we would have 1 for x cubed, -2 for x squared, -12 for x, and then -8. Bring down the 1. -1 times 1 is 0 plus -1 is -1. -1 times -1 is 1. 1 plus 1 is 2. -1 times 2 is, well, -2. -2 plus -2 is -4. -1 times -4 is 4. -12 plus 4 is -8. -1 times -8 is, and -8 plus 8 is 0. And that's what we expected would happen, yes? We knew it would come out to be 0 because it is a solution. What number can we do next? Bring down the 1. 2 times 1 is 2. -1 plus 2 is 1. 2 times 2 is, or sorry, 2 times 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. -4 plus 8 is 4. 2 times 4 is 8, and negative 8 plus 8 is 0. And that's the remainder we expected to get. What number can we do next? Yes. Negative 1 times 1 is? Negative 1. 1 plus negative 1 is? 0. Negative 1 times 0 is? 4 plus 0 is? 4. Negative 1 times 4 is? Negative 4, and 4 plus negative 4 is? Well, how did we know negative 1 was going to work twice? It didn't cross the graph. Because it didn't cross the x-axis, it only touched it. It has an even multiplicity, so there's more than one 0 at that location. So there's 2 of them. Well, now we can't have another negative 1, because if we do, we'll need another. We'll need actually 2 of them. Most likely that's not going to work. 2, it crossed. So you might have 1 or 3. Well, we're not going to have 3. What is the degree of our polynomial right now? It's a degree 2, yes? Because it started out at degree 5. We took away negative 1, and 2, which leaves us with 2 left, a degree 2. So if I plug the variables back in, we would have our remainder. 4 would be the constant. 0 would be the term with x, and 1 would be the term with x squared. So what we're left with is x squared plus 4 is equal to 0. Now, no middle term, so let's go on and use the square root method. Because if there was a middle term, we can just use the quadratic formula. So at this point here, we would subtract 4 from both sides, telling us that x squared is equal to negative 4. And then what can we do? Square root both sides. Square root of x squared is x is equal to plus or minus. What is the square root of negative 4? 2i. Because whenever we take the square root of a negative, the negative is going to come out as I, our imaginary number. So that is 2 of our solutions, and then we would have negative 1, and 2. We have all 5, yes? So we're done. Questions on this here? Are we ready for the next one? Find all the zeros. Well, how many will we have? 3. How many do we really need to find? Because since it's a degree 3, I need to get it down to a quadratic, yes? So if I find 1, I can use synthetic division and take it from a degree 3 to a degree 2, and then we can use the quadratic method or our methods for solving quadratics. How many would we like to find by graphing? Yeah, 3, because if I can find all 3, that's the best. If I can find 2, yes, that's even better. Or not even better, but it's a little bit better. Not as best as 3. Because it'll take it down to a linear, which isn't that bad. But what I don't want to have happen is not to find any. Clear. X cubed plus 7x squared plus 16x plus 12. Graph it. So how many intersections do we have? 2. It looks like 2. This is where having the table works out very well. Okay, so we have -3 and -2. So we do have 2 solutions, which is good. Could be better. I mean, we could have 3. And most likely we do have all 3 here. So -3 and 2. Well, I'm just going to pick -3 to start. It really doesn't matter. 1 for x cubed, 7 for x squared, 16 for x, and 12. Bring down the 1 and let's start the synthetic division. -3 times 1 is 7 plus -3 is almost 4. -3 times 4 is -12. 16 plus -12 is 4. And -3 times 4 is, which gives us a remainder of 0, like we wanted. Any questions on this here before we do the next one? Well, our next number was what? -2. So we do -2 times 1, which is 4 plus -2 is, -2 times 2 is, and -4 plus 4 is. Well, do we have an idea what the other 0 is going to be? It would be -2. Because if we plug the variables back in, what we'd be left with is x plus 2 is equal to 0. And at this point here, we can subtract 2 from both sides, telling us that x is equal to -2. And we can add the other 2 in, which gives us this here. And that's it. Questions on this here? All right. So let's look at this one here. We need 5 zeros. Because if we can get all 5, that is great. But how many do we need to get at least? 3. So degree 5 minus 3 would give us 2. We always want to get 2 less than whatever the total degree is. 5 minus 2 gives us 3, because that's where we want to end up. So again, we can grab the graphing calculator. I'll clear this out. X to the 5th minus 3x to the 4th. Well, if I actually put the 4 up as an exponent, plus 5x cubed minus x squared minus 6x plus 4. And once we get it all typed in, we can hit graph. And just like the last time, it looks like it gave us 2 zeros. Second table. So -1 and 1 are our zeros. It definitely did cross at -1. Did it cross at 1? No, I kind of touched and went up. So we expect to have an even number at 1, which is helpful so that when we do our synthetic division, so we can start out at 1. We would have 1 for x to the 5th, -3 for x to the 4th, 5 for x cubed, -1 for x squared, -6 for x, and 4. We don't need any zeros because we do have all of the variables. We have them all. Now we can start our synthetic division. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. 5 plus negative 2 is 3. 1 times 3 is 3. Negative 1 plus 3 is 2. 1 times 2 is 2. Negative 6 plus 2 is negative. And 1 times negative 4 is, and 4 plus negative 4 is 0. So it does tell us that the remainder for this is 0. All right. What number can we do next? Negative 1. Negative 1 times 1 is negative 1. Negative 2 plus negative 1 is negative. Negative 1 times negative 3 is 3 plus 3 is. Negative 1 times 6 is negative 6. 2 plus negative 6 is negative. And negative 1 times negative 4 is 4. And negative 4 plus 4 is 0, giving us a remainder of 0, which is exactly what we wanted. So it's brought us down to a degree 3. We need one more. We can use one again. Yes. And do this one more time. 1 times 1 is 1. Negative 3 plus 1 is negative 2. 1 times negative 2 is negative 2. 6 plus negative 2 is 4. 1 times 4 is 4, and negative 4 plus 4 is 0. And we get the remainder that we expected to get. Now that we're out of zeros, we can plug the variables back in, but that is fine, because where we're at is that we have x squared minus 2x plus 4 is equal to 0. Send the page here. Now, there's not a greatest common factor between these three terms, and we can kind of see that because x squared is just x squared. We don't have a number in front or something that will go into all three. Now, this time we do have a middle term, so we can't use the square root method, but the quadratic formula works just fine. So we'll have x is equal to, so we have negative b. Well, what's the value of b? So negative 2 is just plus or minus the square root of negative 2 squared minus 4. Well, a is 1 and c is 4 all over 2a. Well, a is 1, so 2 times 1 is 2. Now we can plug everything that's inside the square root, all of this here, into a calculator. I wouldn't use the square root. I would just see what the number is itself. And if we type all that in, we get, I believe it's negative 12. Because 2 squared, or negative 2 squared would be 4. 4 times 4 is 16. So 4 minus 16 would be negative 12. Now, okay. we can simplify the square root of negative 12, because the negative would come out as I, and it would be a 2, because it'd be 2I. The negative would come out as I. 12 is 4 times 3, because the square root of 4 would be 2, and we would leave the 3 inside. Now, we could have moved the negative out, yes? Did you put parentheses around the negative 2? So one other thing we could do, because negative 2 squared is going to become a positive number, yes? So what I will do sometimes, instead of putting parentheses negative 2 close parentheses squared, is I'll just put 2 squared. Because I know that the negative would become positive. So I just drop it, type in 2 squared minus 4 times 1 times 4, and hit enter. That way it kind of eliminates that from happening. Now in the yellow calculator, because the yellow calculator will simplify radicals, it just can't do the negative, is we can pull the I out and take the square root of 12 for the TI30XS, and it'll tell us 2 square root of 3. Are both of the top two numbers divisible by 2? No. So we can divide it all by 2. 2 divided by 2 is 1. 2 divided by 2 is 1. So these here would be our other two answers, and the ones that we found were negative 1, 1, and 1. So that does give us a total of 5, yes? Any other questions on this here? If not, the next that we're looking at is the complex conjugate theorem. And this is the theorem I kept inadvertently, I think, saying yesterday instead of the irrational conjugate theorem. I have a tendency to want to say this one over that one. But it works the exact same way. That if A plus BI is a solution, then A minus BI is a solution. If we have one, we have to have the other. They always come in pairs. Any questions on this here? So, almost exactly what we did yesterday. Write a polynomial function f of least degree that has rational coefficients and a leading coefficient of 1 and zeros of x is equal to 2 and x is equal to 3 plus. So do we have all the zeros listed? No? What are we missing? 3 minus I. If we have one, we have to have the other. Now to find the polynomial, we need to get all of these equal to 0. So for the first one here, we can subtract 2 from both sides, telling us x is equal, not x is equal to, x minus 2 is equal to 0. Really, what did we do? We moved 2 from one side to the other and changed the sign, didn't we? So if we work this one out, well, we would subtract 3 from both sides, telling us that we have x minus 3 is equal to I. And then we would subtract I from both sides, telling us that this is x minus 3 minus I is equal to 0. I think some of y'all might have done the third one, but what would the third one do we think would be? Yes. was really we're just moving it over and changing the sign. Because our first step would be to subtract 3 from both sides, which would give us x minus 3 is equal to negative I. And then we would add I to both sides, giving us x minus 3 plus I. If you can see how we move it without doing the addition and subtraction, that's fine. We can do that. And now we would multiply them all together. Now with this here, because we only really have 2 that are conjugates of each other. We only have one set of conjugates, yes? So those 2 we would multiply first because it's going to give us less terms to work with. So we're not going to mess with the x minus 2 yet. We're going to work with these 2 here because when we multiply through, all of the I terms will cancel each other out. So we multiply this together, x times x would be x squared. X times negative 3 would be negative, and x times I is going to be plus xi. Then we'll do the exact same thing with negative 3. Negative 3 times x is negative 3x. Negative 3 times negative 3 is going to be plus 9. Negative 3 times I is negative 3i. And lastly, we're going to multiply through with I times, negative I times x is negative x I. Negative I times negative 3 is going to be plus 3i. And negative I times I is negative I squared. Okay. Equals 0. Well, xi and negative xi here will cancel out. Negative 3i plus 3i. They cancel out. But that still leaves us with 1, yes? What did we say negative I squared was? Or I squared? I squared is negative 1. So really this here is negative 1. So you can write it above it in parentheses. So let's see what we have left. We have x minus 2 parentheses x squared. We have negative 3x and negative 3x, which makes negative 6x. We have 9 and negative 1. 9 minus negative 1. Well, the negative and negative make 8. So 9 plus 1 is 10. And last but not least, we have to multiply these 2 together. So we'll distribute through x first. X times x squared is x cubed. X times negative 6x is negative 6x squared. And x times 10 is plus 10x. Okay? And now we're going to multiply through with the negative 2, yes? I'm going to show you this here because I haven't shown you guys this yet. But there's a different way that I write this out. That kind of helps me a little bit. Because negative 2 times x squared is what? You don't have to write it this way. I write it this way and just line them up. Negative 2 times negative 6x is plus 12x. Negative 2 times 10 is negative 20. And this here is still equal to 0. For what we are doing here really doesn't make a big difference. I like doing this especially when I have a 3-term and a 3-term or bigger, because then we have a lot more variables to keep track of. This kind of keeps everything in a nice, neat order. Because the more variables we have, the more likely we are to lose one. X cubed doesn't have any like terms. Well, negative 6x squared plus negative 2x squared is negative 8x squared. 10x plus 12x is plus 2x minus 20 is equal to 0. And that's it. So you don't have to write it that way where it's stacked. You can write it just next to each other and combine like terms. Either way works just fine. Any questions on this here? Unless, do y'all want to see another example of one of these? Okay. Because I do have others that we could do, and they do get a little bit bigger. But that is where we'll stop today, because what we do have left is Descartes' rule of signs. And this is named after René Descartes. Y'all know what René Descartes kind of famous for? I think, therefore I am. The same guy. And he also did apologetics. Essentially wrote papers about theology. But that's all we're going to cover today.